Alright, you guys, so again, you guys are having a test coming up for Chapter 9 in our geometry unit. So we're going to go over just a few of the problems from the chapter review, just so that you have an idea of how things may look coming up on the upcoming test. These are all from your textbook, the chapter review for Chapter 9. You may have a little bit more signed than what I'm giving you here, but I'm just going to go over the basic gist of things that you might need to know for the upcoming test as well, going along with this whole thing. So we're going to start with kind of the basics. Again, this is over surface area and volume, and then also three-dimensional solids. So we're going to do a little bit of some drawing of some three-dimensional solids, as well as we'll be dealing with identifying different features of solids, and then also identifying what the surface area and volume is on these. So let's dive right in. Okay, so first of all, identifying vertices, edges, and faces. Okay, not whatever that starts with the P with. That's kind of an error on my part. But identifying vertices, edges, and faces. Okay, so for example, let's take a rectangular prism. All right, the question is, how many vertices, edges, and faces does a rectangular prism have? Okay, so we're starting with, this is number 1, I believe, in your guys' chapter review. But how many vertices, edges, and faces does a rectangular prism have? Well, in order to determine that, you have to have a good idea of what a vertice, face, and edge is. Okay, and if you don't have one, then that's going to be kind of a difficulty. So let's do a quick little re-identification. Okay, so for vertices, okay, if we're identifying vertices, we're identifying a point where multiple edges meet on a three-dimensional solid. So there are actually quite a few of those. All right, so you see one here. Okay, there's one. All right, each of these corners represents a vertex of your three-dimensional solid. Okay, picture this as a Kleenex box. Okay, any corner of that Kleenex box is a vertex. Okay, so we're identifying all of those here. All right, and as you can tell, once we look at every corner, there is 8 vertices there. Okay, each corner where edges meet makes a vertex. Okay, so again, with edges are the lines that make up corners of where faces meet. Okay, so where the faces meet are these different lines here. Okay, different faces on the solids. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 here. Okay, there's 12 edges. All right, that's what we have for the edges of this rectangular prism. Okay, and then how many faces does a rectangular prism have? All right, so again, the faces are just the shapes that are forming around your solids. So if we were to do that, okay, that's a bit too bright of a color. Let's change that up just a little bit. There we go. Okay, faces. Okay, there's one here, here. You have a face. You have faces on either side, and then you have a face on top and the face that is in front. Okay, so that makes 1, 2, 3, 4. The 5th one in the back, and then the 6th one in the front. So there's 6 faces to a rectangular prism, 12 edges, and 8 vertices. That is your solution for this given one. Okay. So vertices, faces, and edges. There, you can see that. All right. Next, draw 2 different nets for a cube by adding an additional square unit to the figure. That's what the question is asking. And again, you might not be able to see the whole thing, so let's back me on a little bit. There we go. So by adding an additional square unit to the figure. So I'm actually going to pull this up on a dock cam. Might come in handy a little bit better. All right. So let's blow this up a little bit. Hopefully you can see that a little better. All right, so you are dealing with a shape at this current moment where you have 5 different pieces or 5 different squares. Okay, now if we were to fold this shape up, you're not going to actually form a cube, because a cube, similar to a rectangular prism, has 6 faces. There's only 5 here. So what this question is asking you to do is to identify 2 different nets for a cube by drawing an additional square unit on this one figure. Okay, so that's what's being sought after here. And I could think of 2. Okay, these are just 2 of the examples that I'm going to give. All right, but you got to make it in such a way so that this entire figure will fold into a cube. And I think there's 2 possibilities here. First of all, we could add one here. Okay? Because then if we fold this up, we are covering the 4 faces that are going to be around the base cube here, and then the sides will filter in as well. There's also another one we could draw. Let me draw this figure again. There we go. Okay, you can see those right there. And so now another possibility is we could draw one coming off of a side here. Okay? Both of these, actually no, that would not work. Sorry about that, that would not work, okay? And why is that? Well, if these two faces would collide with each other upon a fold. So that would not work. I'm messing myself up there. So let's retry that, okay? Maybe I did that on purpose, maybe I didn't. That's for you to decide. Okay, so another possibility is that we just have another piece here. That would actually work as well. So this would work and this would work. There are also many other options that would work, okay? You can draw them out as you need to. This one right here will not work, okay? Because again, if you fold this up like this, that's 2 faces meeting at the top, and you can't have that. That will not make a cube. That'll actually create a collision, and that will not do the trick. So that will not be the case there. All right, that's number 7. Drawing nets. So drawing a net for a regular pentagonal pyramid, okay? Well, if you want to draw a net for a pentagonal pyramid, you first of all have to identify what a pyramid is, obviously. So let's draw that real quick, okay? So pyramid, a pentagonal pyramid, that's what we got here, okay, is a pyramid that is made up of a pentagonal base. Okay, I'm doing the best I can here with this, okay? This is my pentagon, all right? And a pyramid, if it's a pyramid, that means the base or the edges coming off of the base will meet at a single point at the top, okay? So let's draw that. Okay, and then you have this one in the back that's a little bit hidden that makes your pentagonal pyramid. Okay, so there's your pentagonal pyramid. So what does a net look like? Well, again, you have a pentagonal base. All right, so it's a regular triangular pentagonal pyramid. This does not appear to be super regular, but kind of run with it here. Okay, so think about a pyramid. All right, you have a base, pentagonal base here, and you have triangles that are coming up to meet at a single point. No matter what, for any pyramid that you have, the lateral faces of your pyramid are going to be triangles. Okay? So that means what we're going to have coming off of each edge here, if we fold the pyramid out into a flat surface, the triangles are going to fold flat as well. Think of the example we did with the Egyptian pyramids at the very beginning of this unit. So we have triangles that are folding out. And that forms the net. It kind of looks like a starfish, okay? There you go. There's your starfish. All right, so, and again, this can be helpful if you have trouble visualizing maybe the different dimensions of a pyramid when it's in a 3-dimensional form. You could fold it out into a net. And then you can identify, okay, this is the base, this is the height. And you can use that to find maybe the surface area of your different figures. Which, speaking of which, that's probably the key concept from this whole unit. So we're going to kind of touch on that just a little bit. I'm going to change my paper a little bit. All right, so finding surface area and volume. And again, that's the primary focus of this unit, is that you will be able to identify surface area and volume. Okay, so let's begin with this. All right, find the surface area and volume of a 13-inch tall rectangular prism with an 8x22 base. Okay, so what is this asking for? It's asking us to find, first of all, the surface area. Okay, so how do you find surface area? Let's put these back up on the screen so that we remember how all this works. Okay, so first of all, for surface area, for prisms, specifically prisms, okay, just like we talked about in class, you have to find the area of your lateral faces and add that to the area of your 2 bases. Okay, your 2 bases that you will have. Okay, remember a rectangular prism. I'm going to draw it on the piece of paper here because it'll probably look a little bit better. Okay, you guys can kind of see that, okay? So this rectangular prism here, all right, again, what do you have? You have a base here, a base on top, and then the remaining 4 faces are your lateral faces, okay? So that means you have to find the area of each of the faces in order to determine the surface area and volume. Now, there's multiple ways to do this. You could just, first of all, take a look at the different dimensions that you have and be like, oh yeah, well then I can easily determine the lateral faces, okay? The lateral faces, if I want to find L, the area of all my lateral faces, all I have to do is I need to find the perimeter and multiply it by the height. Okay? That's one way you could do it. You could just use the mathematical equation that we've worked with. Or you could draw it out into a net. So let's try that. What's the net of a rectangular prism look like? Again, you have rectangles. And your base, which is likely either a rectangle or a square. Now, again, keep in mind that the net I'm drawing here is not to scale, okay, based on the dimensions that are given in the problem. But note that these are the bases when I draw this, okay, and then all of these are my lateral faces. That makes it easier if you draw it out as a net like this way, because then you can kind of, you know, come up with, oh yeah, these are the lateral faces, and you can just kind of work with all of them at once, and then the bases on top and bottom. So there's 2 ways to do it. I am going to go over the mathematical way to do it, but again, I'll kind of follow along with the net so you can kind of get an idea of what's happening here. So the base of this rectangular prism is 8 by 22, okay? And then the height, which I'm just going to put up here, is 13. Okay? It's 13 inches. So what that means we're going to do is we are going to, first of all, find the area of your lateral faces, okay? That's perimeter times the height. Well, what is the perimeter times the height? Well, first of all, we need to identify the perimeter. Okay, so let's do that real quick. First of all, we know that it's an 8 by 22 base. Perimeter for a rectangle is 2 times the length plus 2 times the width. So let's plug that in. 2 times 8 plus 2 times 22 gives you 60. Okay, so you have 60 there. So we are going to take that, okay, and do 60 times 13. Okay, 60 times 13 gives us 780. Right? So, 780 is our lateral surface area. Okay? But what else do we need to find? So we found our lateral surface area. Okay? Now we need to find our area of our base and multiply that by 2. Why? Because we have 2 bases here. So let's find the area of a rectangle. Okay? Simply length times width. Okay? So we're going to do area equals 8 times 22. And 8 times 22, plugging into your handy-dandy little calculator, is 176. Right? And remember, with this area is 176, but since there's 2 bases, what we're going to have to do to find the total surface area is we're going to have to do 780 plus 176 times 2. And when we do that, we're going to get, once we punch it in, 1,132. That's the correct answer. Right? So, that is how you can find surface area of rectangular prism right there. Okay? And the same rule pretty much applies to the circular cylinder. Okay? It's not really too much different. I'm gonna erase my ink real quick. Okay? So, what we have here, I'm gonna blow this up just a little bit. Okay? We have a right circular cylinder for number 10. Okay? And has a diameter of 8 centimeters and a height of 20 centimeters. Well, let's draw that real quick. Okay? With my artistic abilities that everyone knows I have because I've just got the skills to do it. Not really. Okay, so we're going to take this radius, or the diameter that we have, of 8 centimeters. Okay? Remember, it is a diameter. Key point. Draw your cylinder. Okay? The height of the cylinder is 20 centimeters. Now, usually right circular centimeters are a little bit easier. Why? Well, because you're not dealing with as many dimensions, okay? We're probably not going to draw the net of a cylinder. Not really helpful, I guess you would say, to us to draw out something like that, because it's actually a lot more simple. Let me draw the formulas here on the slide here. So, again, the same rule applies for surface area. When you're finding the surface area of a cylinder, you still do L plus 2b. So that means for a prism or a cylinder, you are still doing L plus 2b, okay, to find the surface area. Now, to find the volume, okay, we actually didn't find the volume of the rectangular prism yet either. But for the volume, let's back it up. I didn't find the volume of the rectangular prism. Volume equals length times width times height. Okay? All you have to do is multiply all those together. So that means 13 times 8 times 22 gives us 2,288. So I'm going to just say the volume here is 2,288. My bad. I just realized I totally missed that. So there you go. 2,288. All right. Back to our situation over here. Okay. So we're finding surface area and volume. Okay. So again, the volume here is going to just be the area of the circle. I'm just going to do A times H. Volume equals So anyway, so surface area equals L plus 2b. Now if we take this piece, to find the lateral surface area here, we're not necessarily doing perimeter this time, because the perimeter is not present on a cylinder, right? On a cylinder, or a right circular cylinder, we are dealing with the circumference, not the perimeter. Let's shrink our thing down just a little bit, okay? So, we are dealing with C times height. Circumference times height. Okay, well, first of all, how do I find the circumference of a circle? We know the diameter, so we can actually find it, because the circumference equals pi, good old pi, times diameter. All right, pi times diameter. So pi times diameter is the one that we're going to do. So all that is 8 times pi. 8 pi. Where's my pi? Which is 25.13. Okay, so 8 pi is our circumference. Circumference equals 25.114, actually. Let's do 25.14. Okay, so that's our circumference. And to find the lateral surface area, multiply that by the height of 20. Okay, so that makes our lateral surface area equal to 502.8. Okay, that's our lateral surface area. Right? So, now we can find the area of our bases, because remember, we have to find, as I pointed out up there, L plus 2b. And I don't know the area of this yet. Now, don't forget, okay, to find the circumference, or to find the area of a circle, it's equal to pi r squared. Note, 8 centimeters is not r, that is d, because it is a diameter, not a radius. So that means we have to divide it by 2. Okay, area equals pi times 4 squared. Area equals 16 pi, which, if you calculate that, is 50.27. Okay? That's the area. Now, to find the total surface area, again, what do? Same thing we did with the rectangular prism. The lateral surface area is 502.8 plus 2 times the base of 50.27. So let's do it. 502.8 plus 2 times the quantity, 50.27, gives us 603.34. Okay? And that is going to be the correct answer. Okay? Might be off by a couple tenths of a decimal or something along those lines. Again, that's not really a huge deal, but that's what it should come around to be. Okay? Now, volume. Again, is just area, which we already found, times height. Okay, we're covering the whole scope of the interior of the solid when we do that. Okay, so that means it's 50.27 times our height of 20. Sorry. Volume equals 1005.4. Ta-da! And there's your answer. All right, flip it over. Find the surface area and volume of a cube with 9-inch edges. Okay, so 9-inch edges. Let's do that real quick. That's actually pretty straightforward. Okay, if you want to find the surface area of a cube, what do you need to do? Well, actually, I could do two things. I could draw the net of a cube. Or do I really even have to do that? Okay, think about what a cube is. Okay, a cube with 9-inch edges, okay, has some specific features that we can remember. All right, so first of all of the faces are going to be the same on a cube. How many faces are there on a cube? Well, there's 6. Okay, so the fact of the matter is, for a cube, since all of these are the same, all we have to do is find the area of one of the faces, which again, how do we find the area of a square? Side squared. And multiply that by 6. So to find the surface area of any cube, you can do 6 times the area of one of the squares that make up this cube. Okay? And we know that our side length is 9. So let's do that real quick. Side surface area equals 6 times, what's 9 squared? 81. 9 times 9 is 81. So 6 times 81 gives you 486. Okay? There you go. Surface area equals 486. All right. So now that you've done that, now we need to find the volume, which is actually also very easy. If all the edges are the same on the cube, that means you just have to take the edge, number of edge, or just the length of the edge, and cube it. Volume equals edge cubed. So that means 9 to the third power is 729. Cubes are pretty easy to work with. All right? Clear as mud, hopefully. All right. Next, we're going to do a couple more surface area and volume problems. Find the surface area and volume of a cone. All right. Now we are dealing with cones again. Cones are a little bit different. All right. First of all, with this one, we know that the cone's radius is 5 feet and the height is 12 feet. So let's draw that on our piece of paper here. 5 feet. Okay? And then our height going up the cone is 12 feet. Okay? Keep in mind what this is saying. It is not saying our slant height. Height and slant height are two very different things, okay? If I were to draw a cone right here, as best as I can, that looks pretty terrible. But my slant height right here is L, okay? That's my slant height. My height is from the middle of the base up to the top. So I know the height and the radius. How on earth do I find slant height knowing that information? Well, this is where it gets a little tricky. Let me redraw this cone a little bit and a little bit larger so that you guys can see it. Okay, here's 5. Here is our height of 12 feet. What does this look like to you? What does this look like? Let me zoom in a little bit more. What does that look like to you? Does that not look like a right triangle? Despite my very terrible drawing. That's better. Right triangle. So this would be an application of the Pythagorean theorem. A squared plus b squared equals c squared. Because what do you need? You need the slant height to find the surface area. Not the height, the slant height. The height here will be used for your volume. But the slant height is used for your surface area. Why? Because the slant is what makes up the surface. Okay? The height is within the interior. The interior involves volume. So, we are finding L here, okay, or finding our hypotenuse. So 5 squared plus 12 squared equals c squared. Okay, 25 plus 144 equals c squared. Okay, what is 25 plus 144? 169 equals c squared. Well, if you know your squares, you take the square root of that, you figure out that c equals 13. So your slant height is 13. So from there, we can now find our surface area. Okay? So, you may know, you guys have a reference sheet to kind of see what the formula is for the surface area of a cone. So let's use that real quick. Surface area here is equal to pi times radius times slant height plus pi r squared. Why does this work? Okay, so surface area equals pi r times slant height. The radius is here, and then your slant height is right here, 13, okay? This covers that change going from the base up to a single point. That's your slant height. This portion here covers the area of your base, pi r squared, just a simple area of a circle. So this formula works. Surface area equals pi times my radius of 5 times my slant height of 13. Okay? Add that to pi times my radius of 5 squared. Done. So surface area equals 5 times 13 times pi equals 204.203 for that. Plus pi 5 squared, which is pi 5 squared, 78.53. And then when I add those together, I get my surface area of 282.74. So that's my surface area, okay, for that cube, all right? And again, checks out. All right, so from there, I found my surface area. Now how do I find the volume of a cone? Well, volume's actually a little bit more simple, okay? Because remember, for any cone or any pyramid, remember this, okay? For any cone or pyramid, volume equals 1/3 area times height. So it's 1/3. Okay? It's a little bit quieter of an with that. But volume equals 1/3 area times height. So again, find the area of your base, multiply it by your height, your actual height instead. Okay? Then divide it by 3. That's basically what this is. So let's do that real quick. Okay? Volume equals 1/3. I already found the area of my base back in the prior problem. Okay? Pi r squared is 78.53. So I'm going to do that. Times 78.53. And then my height is 12, not 13. 13 is the slant height. 12 is my actual height. So I'm going to do 78.53 times 12 times 1/3. And that gives me, wow, 314.12. Ta-da! Make sense? I hope it does. All right. Now let's say we have something totally out of the water. This is not something that is in your chapter review in any way, shape, or form. However, you should do this at the end of your chapter review. Wherever there's any blank space, do this problem with me, okay? Find the surface area and volume of an octagonal prism with apothem length of 5, side length of 7, and height of 14. What I'd say you should do, pause this video real quick, try and see if you can use the area formula, and then apply that to surface area and volume. Go ahead and try and solve this problem for me real quick. Bit of an awkward silence, right? Hopefully you paused that video by now. Start working on the problem. All right, let's do this thing. So, octagonal prism. Let's draw that real quick. It's a nice octagon, right? Nice enough. All right, so prism. That means the octagon is relatively the same up here. There you go. All right, and it's all connected. I'm just going to connect a few of them so as not to confuse. Oops. Yeah, it looks all right. There. Octagonal prism. Okay, that's what you got here. So, we know that the octagonal prism has an apothem length. Again, what is your apothem? Your apothem goes from the center of a shape to the middle point of a side. Your apothem length is 5. Your side length on your octagon is 7. And your height is 14. Now, a net for an octagonal prism is just going to be really, really complicated. So we're going to probably dodge that for this point. Okay? It does work. You can do it if you'd like to. But I'm going to do the mathematical way. So, what I have here is, first of all, I have my two bases. Again, to find the surface area of a prism, it is L plus 2b. L plus 2b. Okay? So, that means I need to find my lateral surface area. How do I find my lateral surface area? Well, remember that lateral surface area is perimeter times height. So that means our perimeter is 7 times 8, because there's 8 sides to an octagonal prism, and the side length of 7. So that makes this 56. Times my height of 14. Okay, so let's punch it in. 56 times 14. Boom. 784. That's my lateral surface area. Now for the area of my base. Remember that the formula for the area of my base is, drumroll please, area equals 1/2 apothem times perimeter. That's what that is. Okay. So, area equals 1/2 times my apothem, which is 5, times my perimeter. And the perimeter is 7 times 8 again, which is 56. All right? So, let's do 0.5 times 5 times 56. Gives me 140. So, this is the area of my base, B, and this is my lateral surface area, L. So, surface area equals 784 plus 2 times 140. Make that calculation. 1064 for my surface area. Okay? So, I've said so a lot. You could go back and count how many times I said no if you want, or so if you want. So, volume equals, we're now finding the volume here, area times height. Okay, so that means we first of all find the area of our base. What is it? 140. Not too shabby. We already found it already. Times our height of 14. 140 times 14 should be bigger than the surface area, and as a matter of fact it is. Volume equals 1960. Again, same rules apply. Let's do a quick refresh. Prisms and cylinders versus cones and pyramids. Prisms and cylinders. To find the surface area, you find the lateral surface area first, and then multiply, and then add it to 2 times the area of your base. Again, you have to determine the correct formula for area to use here. But for lateral surface area, it's perimeter times height for prisms. For cylinders, it is circumference times height. Okay? Cones and pyramids. To find the surface area, you do the lateral surface area plus just the base. One base. Okay? And again, to find the lateral surface area, you have to do perimeter times slant height. Okay? Just as a reminder there. Okay? And that applies to pyramids. Okay? And keep in mind that it's also going to be 1/2 perimeter times slant height. Why? Because they're composed of triangles. Right? So you're finding the area of multiple triangles there. Lateral surface area is, for cones, is pi times radius times slant height. So again, that uses slant height. Okay, that's for the surface area. Okay, and then find the area of your base by your typical area formula. Volume for a prism is length times width times height. Okay, and then for cylinders, it is pi times radius squared times height. Cones. For volume for cone, you have 1/3 pi r squared h. For pyramid, volume equals 1/3 base, area of base times height. Okay? Those are surface area and volume for these types of figures. All right. What if you start with surface area and you need to find something? Well, it's actually really simple, and I'm just going to use this one as a simple example. Okay, I think this is in your chapter review as well. Find the length of each edge of a cube whose surface area is 1176 feet. This is actually really easy. Okay? If you know that the surface area equals 1160. Okay? Remember that the surface area of a cube is composed of 6 times side squared. 1176 equals 6s squared. Okay? So all you have to do is just plug it back in to the formula and then work backwards. Okay? So that's what I'm doing here. I'm going to first divide both sides by 6. 1176 divided by 6 gives you 196 equals s squared. Square root of that, because again, that's the inverse operation for an exponent, s equals 14. Bingo. So, that's the correct answer for that one. And again, for example, if you have surface area equals L plus 2B, if you know the area of a base and the surface area, you can find L, the lateral surface area. Okay, so you can find a lot of different things just by knowing the certain details about different shapes. Okay, work backwards using the formulas that you know to get to the point you need to get to. Okay, and sometimes that might involve finding the lateral surface area, so then you can then find, for example, the height, apothem, those types of things. I think we've done some practice amongst those in class, and if you're not in my class, might want to do some practice separately. Or check out another video related to that topic. Not really going to cover that during this time. Okay. Spheres. Again, spheres have their own unique little formulas here. So if we're looking for the surface area of a sphere with a radius of 14 centimeters, okay, the way we find surface area of a sphere is by 4 pi r squared. Okay. So surface area is 4 pi r squared. So we know that our radius is 14. So let's do surface area equals 4 times pi times 14 squared. 196. So 196 times 4 times pi gives us 2,463. And pretty much that's right on point. Volume of a sphere. Okay, so the volume of a sphere is 4 over 3 pi r cubed. I know my diameter is 18 feet, but that's not a radius. My radius is 9. It's half the diameter. What's 9 to the third? 729. So let's calculate it. 729 times the quantity 4 divided by 3 gives us 972 times pi equals 3,053.63. Okay? That's what you do for spheres. Woohoo! We're done. At least with those. Okay? So again, these are just some examples that are given to you of some basic problems that you might come across in the future. There will be, on the test, likely some questions where you will have to read the question and figure out exactly what you will have to use. It's going to be some more of like some context to some of these problems, like, for example, like a water tank or things like that. It'll give you the details on what you need, but make sure you can apply those well. And if you can do these basic functions, you should do pretty well on this test. So, just keep that in mind. Hopefully this video is helpful, and until next time, whenever that is.